All right, let's start off chapter 5. Let's just call this just like a fresh start, because chapters 3 and 4 and that last module, those kind of grouped together, and we were all talking about lines and linear inequalities, graphing. All right, chapter 5, chapter 6, and chapter 7 all kind of flow together, and they're all going to deal with properties of exponents, multiplying, and factoring. But everything that we do will revolve back to one of these properties of exponents, I think. So let's start off by learning the three main properties of exponents that we'll see along the way. So I'll do 3 videos for 5.1 explaining each of the properties. Well, the first property that we have, we'll kind of develop this on our own with stuff we already know. Just looking at an example real quick. Thinking ahead. Example. All right, what do you think would happen if I multiplied these two terms together? Y to the third times y to the fourth. You might already have an idea. You might be inclined to say, since I'm multiplying, why would I not multiply 3 times 4 and say 12? Right, but if we break it down into what we already know, we can discover what this answer is. Right, y to the third. By definition, if I raise something to the third power, it means I'm multiplying 3 of them together. So this guy right here would be our y to the third. And I'm going to take those 3 y's and I'm going to multiply them by y to the fourth, which by definition would be 4 y's multiplied together. All right, so maybe now we can see a more clearer answer here. If I take 3 y's and I multiply them by 4 y's, and altogether, how many y's are being multiplied? We can just add them up and see that we have y to the 7th. So, in reality, when we're multiplying 2 terms together, right, we can add the exponents up. And that's going to be our first property. Call this property 1 of exponents. And I'll spell it out in a more generic sense. If I have x to the a power and I multiply that times x to the b power, we end up with x to the a plus b. So when we're multiplying terms together, we add the exponents. I'm going to put in a couple pieces of terminology here. When I have a term that's raised to a power, this piece that's below the exponent, right, this x, this is called the base. Okay, so I would need, in order for us to add exponents, we need the same base, or the same variable. It doesn't matter if the exponents are the same, because we're just going to add them up, but okay, we have bases, and these are obviously the exponents. So just a new piece of terminology in there. And when I multiply 2 terms with the same base, we add the exponents. Okay, now we'll just look at a few examples of this and see how different and difficult this could become. Which in the end isn't too complex. If I had x to the 8th times x to the 4th times x to the 3rd. Well, all 3 of these terms have the same base, so I can just add the exponents. 8 plus 4 is 12, 12 plus 3 is 15, so altogether we'd have 15 x's multiplied together. So x to the 15th. going to multiply these two expressions together, a to the 6th, b to the 3rd, a to the 4th, b. Right, it doesn't particularly matter how many variables involved, because each variable is going to be its own game. Right, when I'm looking at this problem, I'm saying, well, how many a's am I being asked to multiply together? Well, I've got 6 a's here, being multiplied by 4 a's here. These two have the same base. So when I multiply them, I'll end up with a total of 10 a's. When I look at the b's, right, these have the same base. So I have b to the 3rd. There's 3 b's here. Right, this doesn't have an exponent. There's no visible exponent, but and if there's nothing written up there, it's assumed to be a 1. So there is 1 b over there. I have 3 b's in this pile and 1 b in this pile. When I group these together, I'll have a total of 4 b's. So a to the 10th, b to the 4th. So it doesn't matter how many variables there are. You just treat them in their own separate little game. So we can throw in some coefficients now. Coefficients don't make this problem any harder, but you do treat coefficients differently than you do bases and exponents. Right, so this 8 and this 3, these guys are coefficients. And we talked about that term before. Right, coefficients, right, these work like normal whole numbers. This is a whole 8 times a whole 3. If there was nothing else in this problem, it would literally say 8 times 3. So you treat it as you would any other whole number situation. 8 times 3 is 24. Right, but when you come to the bases with the exponents, now you treat them with our exponent property. So they have the same base. Add the exponents and y to the 11th. So 24y to the 11th. Let's do one more example. Negative 5x to the 3rd y times 2xy. And treat your coefficients normally. Negative 5 times 2, that's a negative times a positive. That should multiply to get negative 10. Right, in terms of my x's, I have 3 x's in this pile and an extra 1 over here, so I have a total of 4 x's. And in terms of y, we have 1y in the first expression, 1y in the second expression, so we have a total of 2y squared. All right, so there's our first property. All right, when we multiply terms with the same base, we will add their exponents.